Hello students, so here we are back again with our 7th lecture, and today we'll discuss about refractive index. So hope you guys are enjoying the videos, and let's begin without wasting any time. Refractive index. Now what is refractive index? Let's know first, then we'll go through the topic. Refractive index. When you are talking, we know that if light travels, light's nature is to travel in the straight line. Light को हमेशा straight line ही जाने का मतलब उसका nature क्या है? Straight line जाने का. But what happens if light travels from one medium to another medium? Light bends, and this bending of light is called refraction. Now the question comes, for example, say light is traveling from air to water. Light is traveling from air to water, and light is traveling from air to glass. In both of the cases, refraction will happen. When light is traveling from air to water, some amount of refraction will happen, and when light traveling from air to glass, refraction will also happen. But the question comes, in air to water or air to glass, in which case refraction is more? This amount, what is the amount of refraction is happening? We can understand by using what? Refractive index. This refractive index will tell us amount of refraction, how much refraction is happening. For example, if I say refractive index of water is what 1.3 and the refractive index of glass is 1.5, that means refractive index of glass is more. That means the light will bend more in glass. That means refraction will be more in glass as compared to water. Hope you guys understood what I'm telling. Refractive index means amount of how much refraction happen when light traveling from one medium to another medium. Okay, so to understand this refractive index, we have to know about the second law of refraction. And second law of refraction is what? Second law of refraction is given by Snell, 1962 or 61. So 1962, I think. And the second law is what? According to Snell, then when light is traveling from one medium to another medium, then there is what? There is an incident ray and there is an incident angle. The sine of angle of incident, and the sine of angle of what? Refraction. Sine of angle of refraction is a constant. Is a constant, and this constant is known by what? Refractive index. When light, this is our second law, for a given pair of medium, angle of incident of sine and angle of refraction of sine is a constant, and this constant is known by refractive index. This constant is known by refractive index. Let us understand. For example, say light is traveling from air to glass. Say angle of incident is what? Say angle of incident is 37 degree and angle of refraction is what? 24 degree. Angle of incident is what? 37 degree and angle of refraction is what? 24 degree. So if I put here sine 37 degree and what? Sine 24 degree. So what is the value for sine? If I remember, then the sine 37 value is 0.64, and the sine 24 value is what? If I remember, then 0.40. If I cut this 2, I will get 6 by 4. If I this 2, then 3 by 2, I will get 1.5. Then when light is traveling from air to glass, this constant is what? 1.5. That means the refractive. What is the value for refractive index? Value of refractive index is what? 1.5. The question comes, whether this refractive index is depend on angle of incident. Answer is no. Refractive index is not depend on angle of incident. It is the ratio of sin I by sin R. When you are talking about refractive index, we are strictly talking about sin I by sin R. We are strictly talking about when light is traveling from air to something. For here we are air to glass. Instead of air, we can write also vacuum. We can also write what? Vacuum, because speed of light in vacuum, strictly if we are saying, then we will use when light is traveling from vacuum to glass. But speed of light in vacuum and speed of light is here almost same, 2.9979. In case of vacuum, it is 2.9979 10 to the power 8. In case of air, it is 2.9970 10 to the power 8. That means both of this speed of light in vacuum and speed of light in air is almost same. That's why instead of vacuum we can use what? Air. Instead of air we can use what? Vacuum. These two are same. Okay. So when you are talking about refractive index, the refractive index is 1.5. That is the ratio of sin I by sin R is a constant. Now refractive index, what? It gives us the, if the refractive index is more, then the venting will be more, refraction will be more. This gives us an idea how much refraction will happen, how much bending will happen. Hope you guys are understanding. This formula of refractive index is based on angles, incident angle and the refraction angle of refraction. Okay. So from this we can say what is refractive index? The refractive index is nothing but the bending ability of light. How much light will bend, or how much refraction. It is the ability of refraction. How much refraction will happen. These things we can understand by using what? Refractive index. Say what is the refractive index of glass? Refractive index of glass is 1.5. That means that, and the refractive index of glass we are saying what? 1.3. That means what? Refractive index in case of glass will be more. Sorry, refractive index of glass 1.5 and the refractive index of water is 1.3. This means what? Light will bend more in what? Glass than with compared to what? Water. Okay. Hope it's clear. Now, when we are talking about this refractive index, then there is a relation between what? This question may come in exam. Angle of incident was 37 degree, angle of refraction was 24 degree, and find out the angle of what refractive index. Okay, you may note down this one. Next topic. Next, if I mention, what is this? Okay. The refractive index. Now, refractive index and speed of light. Refractive index and speed of light. There is a relation between refractive index and speed of light. Okay, let's see what. For example, to understand this, we need to take a case. Okay, let's take a case. Light is coming from air and entering into what? Entering into glass. Like that. We have taken the case as the previous one. Light is coming from air and entering into what? Glass. With a speed of v1, and after its nature is to travel with a straight line, but light will what? Light will bend. And this bend, after the bending, say speed is what? v2. Now, refractive index in case of medium, this is our medium 1. Here is our medium 1, and this is our medium what? 2. Medium, light is entering from medium 1, light is coming from medium 1 entering into medium 2. Now, what is refractive index? Now, if I am saying refractive index, we will compare with the medium 1 with respect to medium 2. We will find out the refractive index of medium 2 with respect to what? Medium 1. Refractive index, we used to denote this refractive index with the letter what? N. N is the letter that we use to denote what? Refractive. Instead, sometimes there is what? And mu is also there, but in class 10 there is what? N is. Usually they give question from what? By using what? N. N is the refractive index. Okay. Upper classes you will find what? Mu is there. So refractive index is what? N. So this refractive index, for example, medium 1 is what? Our air, and medium 2 is what? Our glass. Light is coming from what? Air and entering into what? You say what? Glass. Medium entering into us. Here is velocity, speed is what? v1. Here speed is what? v2. So N. I am saying what? Refractive index of glass with respect to air. Refractive index of glass with respect to what? Air. Now that is refractive index of medium 2 with respect to medium 1. This N1 2 we can write as what? v1 by v2. Refractive index of medium 2 with respect to medium 1 is equal to the ratio of speed of light in medium 1 by medium 2. Now why this relation? Because we know that the refraction happens because of changing in the speed of light. As light is traveling from one medium to another medium, then there is change of speed, and because of changing in the speed, what happens? Refraction happens. Because of changing in the speed, refraction happens. So there is a relation between the speed of light and the refractive index. And what is the relation? Refractive index is the ratio of speed of light. And when I am talking about the refractive index of medium 2 with respect to medium 1, that is what? v1 by speed of light in medium 1 by speed of light in medium 2. Now we can write this one also as like this N21. Don't use this N21. Just read this way. N21 is equal to medium by speed of light in 1 by speed of light in 2. Or you can also read this way. is refractive index of medium 2 with respect to medium 1. Now what will happen if I say light is coming out of the glass, entering into what? Air. Now what? Here refractive index of air with respect to what? Glass. Air with respect to glass. So I will write what? N1 2, N1 2. Here refractive index of 1 with respect to what? 2. With respect to what? 2. So here will be what? V2 by V1. V2 by V1. V2 by V1. So I can also write N1 2. N1 2 is equal what? V2 by V1. Hope you are understanding. So what is refractive index? The refractive index is the if you are using speed. So if you are using angle, then it is what? Angle of incident of sine by angle of incident of what? Angle of refraction of sine. Sine of angle of incident, sine of angle of refraction divided ratio. Okay. If you are using the speed, then the formula become what? N1 to V1 by V2 and N21 V1 by V2 and N21 V2 by V1 and N1 to V2 by V1. Okay. This is based on speed of light. Now in upper classes you will also find the refractive index is also, for example, if I am saying N12 refractive index of medium 1 with respect to medium 2, this can represent it as the ratio of refractive index of 1 by refractive index of 2. Upper class you will find, if I am saying what is the refractive index of 1 with respect to 2 is the refractive index of 1 by refractive index of 2. But in your class 10, this one is important, where speed one is important and the angle of incidence sometimes they may ask, but mostly they ask from this speed of light. Okay, so refractive index, why refractive index have a relation with the speed? As speed, because of changing in the speed there is refraction is happening. So refractive index is the ratio of speed of light. Just note down this one. Now refractive index, if you are discussing, then there are two things about this. One is what? Absolute refractive index. One is absolute refractive index. One is absolute refractive index. Can anyone say what is other? This is what you said. Relative. Another is what? Relative refractive. Relative index. Relative refractive index. One is refractive index. One is relative refractive index. Another is absolute refractive. Now relative for what? If we are saying relative, for example, there are 50 students in a class, and you are comparing any two student with any two student with and you are comparing any two student without what? Except the best one of the class. Say you are comparing 49 and the 49 and the 50. You are comparing. But when you are compare relative refractive index, in case of relative refractive index, it is the for example, light is traveling from glass to water, any two medium. It is for any two medium except air or vacuum. This relative refractive index happens for any two medium except air or vacuum. Because why? Because in case of absolute, if we are talking about the absolute, this is the comparing. In case of absolute, we will compare the one medium with the best one, and the best medium is what? Our air. Okay, try to understand this way. In case of absolute, we will compare with the best one, and in case of relative, we will compare any two. Say what? Glass to water. So what is the refractive? Say N refractive index of air with water with respect to glass. Water with respect to what? Glass. So is equal to what? Speed of light in what? Speed of light in what? Water by speed of light in what? Glass. As we said, N21 is equal to what? V1 by V2. So what? N refractive index of glass with respect to what? Water. With respect to water is the speed of light in what? Water by speed of light in what? Glass. Speed of light in glass. But if we are talking about absolute refractive index, then we will compare the refractive index of one medium with respect to air or vacuum. Now why we are using air and vacuum? Because the speed of light in vacuum and speed of light in air almost same. So instead we can use anyone. if you are talking about the refractive index, is the ratio of speed of light in any medium divided by speed of light in what? Speed of light in, there is a formula for refractive index, n equal to c by b, n equal to c by b. This c for speed of light in medium, speed in medium, I'm writing shortcut, speed of light in medium, speed of light in air, speed of light in air by speed in medium. So in case of absolute refractive index, we will compare the refractive index of one, we will compare the refractive index of one medium with respect to the air, but in case of relative refractive, we will compare any two mediums, say glass, water glass, say glass, then the diamond, then there is any medium you can say. So if except the air and vacuum one. So in case of absolute refractive index, there is what? N equal to c by b. N equal to c by b. C is what? Our speed of light in air or what? Vacuum. And we know that this we can use it for 3 to 10 to the power 8. This is a common thing. You have to remember. Speed of light in air is what? 3 to 10 to the power 8 meter per second. Exact value is 2.77990, I think. Okay. So exact value already in first part I have discussed. So speed of light in what? 10 to the power meter per second, and the medium speed will given after by using this we can find out the value easily. Okay. So here from this they make ask question. For example, now say an example, speed of light by using this. Okay. So a relative refractive index what? Relative refractive index what is the, when you compare with any two medium, for any two medium, but absolute for we will compare with the best one, and the best one is what? Our air or vacuum. Hope you are understanding. Okay, just note down this. Okay, now let's solve a numerical regarding this by using this word absolute refractive index. Say speed of light. What is the refractive index? What is the refractive index for light entering air to glass, of light, refractive index of glass when light entering from air to glass, speed of light in glass 2 into 10 to the power 8 meter per second. That's all. What is the refractive index? Question is what is the refractive index for glass light entering from air to glass? Light मतलब यार्ड से मतलब glass पे घुस रहा है, मतलब for that is we find out the refractive index, and the speed of light in glass is what 2 into 10 to the power 8. So here our medium is what? This is the case of light entering from air. If you are talking about air, then it is absolute refractive index, and what is the formula? N equal to c by b. N equal to c by b. C for speed of light for air, and V for speed of light for medium. The medium about whom we are talking about. So here medium is what? Our glass. And our main medium, absolute medium is what? Our air medium. So given is what? Given speed of light in glass. The medium speed is what? The V equal to 2 into 10 to the power 8. And C we know that what is the value of speed of light? What is speed of light? 3 into 10 to the power 8. 3 into 10 to the power 8. 3 into 10 to the power 8 meter per second. So n equal to question mark. Refractive index equal to question mark. Since n equal to what? C by b. So what is the value for C? C is 2 into 10 to the power 8, and the V is 2 into 10 to the power 8. If I cut this 2, if I divide 2 into 1.5. So what is the refractive index? The first case also angle of incident of sine. The refractive index of glass was 1.5. Here also refractive index is what? 1.5. That means if you are doing anyway, refractive index will come what? Same. Now the refractive index 1.5. This means what? What question may ask come like this. The refractive index of glass is 1.5. Refractive index of this is very important. 2018 one question came. The refractive index of diamond is 2.42. What does it mean? The refractive index of glass is 1.5. What does this mean? This means that the ratio of speed of light in air and speed of light in what glass is what 1.5. मतलब लाइट मत रिफ्रैक्टिव इंडेक्स 1.5, इसका मीनिंग मतलब क्या है, द रेशियो ऑफ स्पीड ऑफ लाइट इन एयर by ratio of speed of light by what speed of light in what medium is what 1.5. Ratio of speed of light in air with ratio of speed of light what in air with what speed of light in what glass is 1.5. If you are talking about the refractive index of diamond is 2.42, this means what ratio of speed of light in air with speed of light in diamond is 2.42. Refractive index of water is 1.3, means what speed of light in air with speed of light in water is 1.33. okay, this like you can refractive index of kerosene is 1.44. what does it mean? This means that the refractive index, this means the ratio of speed of light in air with speed of light in kerosene is 1.4. okay, hope you guys understood this one. So this is very very important. Question may come like this. Other way they may ask, they will give the value for this 1.5 say see what is the value speed of light in medium, speed of light in medium. This they may reverse the question. Speed of light in medium, if c equal to this and n equal to 1.5. So if this happens, then n equal to c by b. We have to find out what v. So v equal to what c by n. So what is the value for c? 3 into 10 to the power 8. And what is the value for n? 15 to the 30. So it will give answer will come 2 into 10 to the power 8 meter per second. They may ask the question like this also, where they will give the value for c, they will give the value for n, they will ask about find out the refractive, they will find the speed in medium. They will give any two and you will find out the one. okay, try to do more from this. I will try to put some of the questions in our description box, so check out the description box. okay, hope you guys understood this one. So make a note and let's proceed with the next one. Make a note. Note down this. Then the next question is, if somebody asks you, refractive index depends on what? The refractive index is not depending on the angle of incident. Then what are the things that on which refractive index depends? Though this kind of question not very much important for class 10, upper class is very important. But if somebody may ask, then what things refractive index depends? We know that everything is dependent on something. So refractive index usually depend on two things. One is what? Material. For example, what kind of thing is this? For example, if you're talking about glass, we're talking about diamond, we're talking about water. For different what kind of material it is. Okay, the kind of material, kind of substance. First point. And the second point is what kind of light used. What kind of light used? What kind of light used, or what is the wavelength of the light? Wavelength of the light. Okay, so these are the two things on which refractive index depends. Refractive index depends on the kind of material, and number two depends on wavelength of light. Wavelength of light, or what kind of light is used. Now, if somebody may ask you, for what happens when light travel from one medium to another medium, and both the medium have the same refractive index. For example, take medium A and take medium what B. Now you may if I ask you, what will happen if light traveling from medium A to medium B, and both have same RI, refractive index, both medium have same refractive index. What will happen? If somebody asks you, what will happen with the light ray if light is traveling from one medium to another medium and both medium have the same refractive index? What will happen? Yeah, exact. So if light is traveling from both medium A to medium B, then what will happen? There will be, if the both medium have same refractive index, very good. If the both medium have same refractive index, then what will happen? There will be no bending of light. As the refractive index is same, so there will be no bending of light. That means there is no refraction. अरे बाबा सिंपली तो मारते मतलब if the light is same medium traveling, the light will travel with a straight line. मतलब if the refractive index is same, then the medium is what? Same. Glass को हमेशा मतलब glass, now there is a question, अगर different type of glasses are there, so for that in different type of glasses refractive index will be different as all glasses are not made up of same thing. Okay, so if you are talking about same kind of glasses, the refractive index is same and the refraction will be same, so light will travel with the straight line. Very good, fasting this one. Clear? Now the question comes again, mind. What will happen if the light traveling from different refractive index? For example, A to B. Again, I'm taking A to B. Try to understand. Okay, A to B. But this medium has refractive index 1.3. Say this is what water, and this medium has refractive index. Say what glass 1.5. Now what will happen? If light is traveling from one medium to another, both medium have different refractive index. Here will the case refraction will happen. as there is changing what refractive index, changing what refractive index, so there will be what, there will be what refraction, light will bend, and as the light is bending the refraction will happen. Now how this that means on the basis of refractive index, on the basis of refractive index we can also say refraction will be more or less, refraction will be more or less. Okay, to understand this we need to, already we have discussed about rarer medium and the denser medium. Now denser medium and the rarer medium, now there are two things. When we are talking about the rarer medium density is what, less, then optical density is less, but denser medium density is more. Now there are two things. When we are talking about the rarer medium, this is optically rarer medium, and when we are talking about the denser medium, optically denser medium. Now one thing is very, you have to keep in mind that when you are talking about the rarer medium or denser medium, we are using optically denser, and optically denser and optically rarer is, optical density is different than the mass density. To understand this, let's take an example of kerosene. Kerosene's what, kerosene's optical density is what, the refractive index is what, a refractive index optical is almost same. So kerosene's optical density 1.44, then refractive index of water is 1.33. The optical density of water is 1.33 and the optical density of what, kerosene is 1.44. That means from this we can easily say the optical density of kerosene is more with what, than what, water. केरोसिन का ऑप्टिकल डेंसिटी ज्यादा है, किससे ज्यादा है, वाटर से ज्यादा है. बट इन एक्चुअल, इन मास, इफ वी आर टॉकिंग अबाउट द व्हाट, मास डेंसिटी, द मास डेंसिटी इज व्हाट, in case of mass density we know that was kerosene is less denser than what, water. That's why if you mix kerosene and water, kerosene always stays at the top because kerosene density is what, less than water. But optical, if we are talking about optical density, this is different than the mass density. Optical density of kerosene is more, okay, and then what, water. So don't mix these two things. Optical density, when talking about rarer medium, this is optically rarer medium. When you're talking about the denser medium, optically denser medium. Now from this thing we can conclude that the what, for example, if we are saying what, kerosene, I'm taking example 1.44, it's if refractive index, and the refractive index of water is what, 1.33, refractive index of glass is 1.5, refractive index of turpentine is 1.47. So these are the refractive index of some medium. So now if I look closely, in which medium refractive index is more, refractive index is more in what, this is what glass, this is for what, glass, this is for turpentine, this is for turpentine, this is for water, this is for water, and this is for what, kerosene, this is for kerosene. If I observe carefully, you'll see that the what, refractive index is more in what, glass. If the refractive index is more in what, here, now there are two things. If the refractive index is more, refraction will be more, bending will be more. Now this bending will be more is for example, light is traveling from air to, sorry, what, water to glass, water to glass, okay, water to glass, and similar water to, light is entering from water to kerosene, two cases, okay, water to glass and water to kerosene. I'm taking two cases. Here refractive index 1.33, here also 1.33, here refractive index 1.5, here refractive index 1.44. Now as the refractive index of glass is more, the light will more bend. Now why they will more bend? As the speed will be less. Now higher the refractive index, less is the speed of light. Less is the speed of, that means speed of light and the what, refractive index are what, inversely proportional. Higher the refractive index, जितना बड़ा refractive index होगा उतना ही कम क्या होगा, speed of light. Here as the refractive index is more in case of glass with respect to what, kerosene, so light will more bend in glass in case rather than what, kerosene. Kerosene में light will bend, इन दोनों केसेस लाइट बेंडिंग होगा, मतलब बट केरोसिन में क्या होगा, ज्यादा होगा, सॉरी केरोसिन में क्या होगा, कम होगा, ग्लास पे क्या होगा, ज्यादा होगा. क्यों ज्यादा होगा? बिकॉज हियर स्पीड इज लेस, तो बेंडिंग क्या होगा, ज्यादा होगा. ओके, हियर बेंडिंग दोनों में होगा बट हियर बेंडिंग थोड़ा कम होगा बिकॉज इनमें क्या होगा, रिफ्रैक्टिव थोड़ा कम है. तो हायर द रिफ्रैक्टिव इंडेक्स, लोअर इज द स्पीड ऑफ लाइट, लोअर इज दिस रिफ्रैक्टिव इंडेक्स, हायर इज द स्पीड ऑफ लाइट. यहाँ पे अगर पूछे जाए तो किनमें लाइट की स्पीड किनमें सबसे कम होगा, तो ग्लास पे सबसे क्या हो जाएगा, कम हो जाएगा. सबसे ज्यादा किसमें होगा, वाटर पे सबसे ज्यादा हो जाएगा स्पीड ऑफ लाइट इन केस ऑफ दिस थिंग. Now in which case refraction will be more, so refraction will be more in what, glass. Okay, hope it's clear. So we have discussed about refractive index, we have discussed about the refractive index, absolute refractive index, relative refractive index. We have also discussed about the relation between the speed of light and what refractive index. Then we have discussed about this concept of what optically dense or optically rarer medium, and what happens when light travel from different refractive index medium. Now I'm taking the first case also, speed of light 1. For example, I'm taking refractive index of medium 2 with medium 1 is what, v1 by v2, and refractive index of medium 1 with respect to medium 2 is what, v2 by v1. Now what is happening here? If you observe, you will see what, then the refract both these two medium. If I write 1 refractive index of medium 2 with respect to what, medium 1 is equal to 1 by refractive index of 1 with respect to what, 2. That means when you're talking about the refractive index of one medium 1 to medium 2, they are same but reciprocal of each other. Here if you see v1 by b2, if you reciprocal this will be v1 by b2. So both, if you're talking refractive index of medium 2 with respect to medium 1 is equal to the refractive index, is equal to the reciprocal of refractive index of medium 1 with respect to medium 2. Now from this examiner may ask question, if the refractive index of light entering AR to glass is 1.5, what will be the RI when light comes from enter from glass to here. So here light entering AR to glass, that means what, AR to glass is what, 1.5. We have to find out what, glass to here equal to question mark, glass to here. Solution I'm doing, refractive index of light and light AR से मतलब glass पे, AR to glass is 1.5. What will be the refractive index light, glass to water, AR to glass 1.5, glass to air, question mark. Now from this we can easily say that since glass to air is equal to the reciprocal of air to glass, so 1 by 1.5, if you calculate 1 by 1.5, if you calculate you will get 10 by 15, if you divide you will get 0.67. This is the answer. Okay, this kind of question may ask in exam. So you just do one thing, just pause the video and try to make a note from this and go through the book after this so that you can understand more. And if you are facing any kind of doubt, you can message me on join my Facebook, and you can message there, or you can directly message in my WhatsApp also. I will try my best to reply. Okay, this is all about today's lecture. Thank you so much, and share with your friends so that they also get the benefit. Okay, bye bye.